Hello, this is dumediat. I hope you're all doing well. Today I'm bringing you a video of a puzzle called Sistine Hippos by Philipp Blume, also known as Glum Hippo. This puzzle was sent to me a little while ago, so apologies to Glum Hippo for taking so long to make this recording. But I don't have much to say today other than let's get into the puzzle. I'm excited to solve this one. I always enjoy Glum Hippo puzzles. So we have normal Sudoku rules. So we have the digits 1 to 9 without repeats in every row, column, and 3 by 3 box. We also have arrows in the grid. So whatever digit we place in the circle, let's say we put a 4 here, that means that these two digits that we place in these cells along the arrow must sum to 4. So this would need to be a 1 and a 3, for example. And this could be anything as long as it's valid, and digits are allowed to repeat along arrows. So for example, this one could still be a 2. We could have a 1 here and a 1 here. That would be a valid way to fill that arrow. And then we have killer cages. So these caged cells will contain digits that sum to the number in the top left corner of the cage. So these two cells, whatever digits we place in them, they must sum to 8. So we could do 1, 7, for example. That would be okay. But digits are not allowed to repeat in cages. And it looks like that's only going to affect this cage because every other cage is all contained in one row or column. So for example, if we wanted to add to 29, let's just say we did 3, 4, 5, 6 here, which gives us a sum of 18. We need these to be 11, but we couldn't use 3, 4, 5, and 6, so we would have to use 2, 9, for example, to make that work. Those are the rules. I encourage you to try this puzzle yourself. I'm going to get started now. Let me restart my timer. Let's see how we do with this puzzle. So the first thing I usually do in these killer puzzles is to look for kind of freebies with the killer cages, but a lot of these cages are very kind of middling as far as the sums. Yeah, even this 29 cage, that's in 6 cells, so the average digit in that is just above 5, so right in the middle. So I don't see anything we can do right now just looking at the killer cages by themselves. And same thing with the arrows. We don't really have any 3-cell arrows where all the digits see one another, so we can't like restrict the arrow circles. We can a little bit, but not enough where I want to pencil mark that. Sometimes there's some tricks where you can look at the combined sums of some arrows, but the problem with these arrows is, like, normally if we were to look at these 4 cells, for example, we know that the minimum sum would be 10. And so if we put the digits 1, 2, 3, and 4 in these, and then the minimum sum of these two would be 3 with 1 plus 2. So we'd have 13 here with these 6 cells, and then 14 with this cell. So that would be a way we could maybe restrict that. But the problem here is that there's 2 arrows coming off of each of these circles in these 7 cells. So if we said this was 14 as the minimum, normally we'd think we could maybe do have these 2 arrows sum to a minimum of 14. But in reality, it's these sum to a minimum of 14, but that's being cut in half because this is taken up by 2 of these cells. So for example, these cells are just this twice. So if this was a 6, this would be 6 and 6 for a total of 12. So since these are a minimum of 14, it's really 7 and 7. So the minimum sum for both of these 2 arrowheads is 7. So again, that's not very restricted. And we don't get any cool tricks like that. I don't see also, we can kind of restrict where 9 goes. That's another thing you can look at because 9 can never go on an arrow that is more than 1 cell long. So we can't put 9 in any of these cells, but they go here just fine. In this box, we can't put 9 in any of these cells, but that doesn't seem very restricted. Even in rows like this row, we can't put 9 in those, but 9 can still go in any of those cells. Something else that might be helpful maybe if we look at the combination of these arrows, because I'm noticing the arrows kind of overlap these cages quite a bit. So if we think about this cell here is going to be some number between 1 and 9, well, between 3 and 9. Let's just say it's 6, just for example. That means that these 4 cells are going to sum to 12 because we have one instance of 6 here and we have one instance of 6 here. So these will sum to 12. So that would have a value of, that would be what happens. So in this case, we don't know what the sum is of these 4 cells. I'll make these yellow just for now. But it's whatever the sum is, we'll cut that in half, and that's the number that will go, this digit that will go in this cell. But we also know that these cells here sum to 19 with this 8 cage and the 11 cage. So if I make those, I'll make those blue. So these blue cells sum to 19. And so if we, see, it doesn't really help if we don't know the sum, but let's see if we can figure out the minimum here. So of this. And the way we can do that is just to say, like, we know this is 19 and this is 2x, and x is the digit that goes in here. So if x is 3, for example, that's going to break immediately. So let's use 5. That means that these sum to 10, right? These yellow cells, and these sum to 19. And you see these 3 cells overlap, so we can get rid of the color from these. And so we can say that the difference between the original 19 we had and 10 is 9, with this being the smaller number. So we would say that this digit would be smaller, 9 smaller than this, which is impossible in a Sudoku. And I can just walk through that. If this is 5, we can use 1, 2, 3, and 4. And whatever combination we get to, this would be 10. But even if we max this out, this is 2 plus 3 plus 4 equals 9. And we don't have to, we can use repeated digits here. So we could even do like 4, 3, and 4, 4, 3, 4. And that would be 11. So this would have to be at least 8. It could be 8 or 9. But then again, we have, if this is 8 or 9, then these cells sum to 11 or 10, because these blue cells sum to 19. So if these are 11, that's already too much for this, because these, remember, add only to 10. Or if it's 10, then that means that this cell would have to be 0. So we know that this is at least 6 because of that. Now if it's 6, that means these sum to 12. And so if we do this canceling out again of these cells, we know that if this was 12 and this is 19, that means this is 7 less than this cell. And so if we make this 9, this could be 2 or 1, and this could be 8, for example. So we have a relationship between these 2 cells. But I don't know that gets us very much. Maybe it'll be better on this side. In fact, yeah, let's go over here because these overlap a little bit nicer, I think. It's going to be similar, but I think it's a little nicer. So I'll go ahead and use some different colors over here. I'm going to use orange for these. So again, this is 2 instances of whatever digit goes in here. So this is, we'll call it 2x, where this is x. And then these cells sum to 16. And I'm going to color those, I'll just make them purple, so they stand out. So I think this might be like less restricted in this case, but maybe not. So if this is 16 and this is 2x, what happens if we put a 5 here again, just to see what this is going to be? These arrows are going to be, again, 1, 2, 3, and 4, because we can't put any higher than 5 on these lines. And so if we made, well, this is going to break already. Okay, yeah, so we can't put 5 in here because we can't put any digit higher than this number on these lines. But in order to make a sum of 9, we need to use at least one digit that's 5 or higher. So this can't be 5 either. Let me just delete this. This has to be at least 6. So if this is 6, the highest digit we can put on 9, or the only way we can make the 9 sum, because we can't use any digits 6 or higher, is 4, 5. That's the only way that's going to work. Now these have to be different. So one's a 4, one's a 5. So if this is 6, then this is a 1, 2 pair. And so we have a sum of 12 in these. And this has to be, to make this work, this has to be either 2, 5, and 1, 6 won't work. But just to show kind of what I'm talking about here, the relationship between these two cells. So these add to 12, and this adds to 16. So this cell has to be 4 higher than this cell, whatever that is. Okay, now something tells me that this particular case won't work, but yeah, because if this is 4, 5, this is already 6, so this can't be 6. So just to put this out on here so we can help visualize, this is a 5, 2. This has to be a 1 because that was a 1, 2 pair. Now the 5 makes this a 4 and this a 5. And this actually does work. We got 4 plus 5 is 9, 5 plus 2 is 7, and then we've got this arrow and this arrow working. So this could be 6. But the point is, this is at least 6. I wonder if there's any sort of generalities that can be drawn here. Because if this was 6, so this was 12, and this is 16. So that means that this cell was 4 more than this cell, which there's a lot of ways to do that. If this is 9, oh, here's one. So this can't be 8. Because if this is 8, then the orange equals 16, but the purple also equals 16. So if we cancel out the digits that are shared with that, we should be able to say the sum of purple is still equal to the sum of orange. So if we do that, that means that this cell, well, remember, these were 16 and these were 16. So the difference is 0. So the difference between these two cells would be 0. And that won't work because they're in the same box. They'd have to be the same digit. That's pretty cool. So this can't be 8. If this was 7, these would be 14, and these are 16. So if we cancel these out, this is 2 more than this cell. And if this is 9, these are 18, and these are 16. So this is 2 more than this cell. And if this is 6, again, this is 12 and 16, so this is 4 more than this cell. The leftover purple cell is 4 more. Is there something else we can do over here with these two? These two cells don't see each other like these two did. I'm going to go ahead and put the colors back in these cells just so we can help keep visualizing these. So if this is 6. Again, these are 12. And these are 19. So this is 7 more than this cell. Even if this is 9 and these are 18 then, these are 19, so this is 1 more than this cell. Not quite seeing how that breaks. I can feel that this is the break-in, but I'm missing something key here. Because I don't see any other place that these arrows really interact with these overlapping cages. So I don't know how else we would be able to restrict this. Let's try this one again, because this has to be the most restricted one. So if this is 6, we walked through that, and I believe that worked. What about if this is 7 and these are 14? These are 16, so this one is 2 more than this one. And 19, that meant this was, these are 18 on orange and purple is 16, so this is 2 more than this one. But this one is a little more restricted on how high it can be because it's in a 7 cage. So these are from 1 through 6. Let's see what happens if this is 7. If this is 7, the reason I'm doing this is because I see these 2 cells sum to 7 and these 2 cells sum to 7. That's the point. Okay, that's pretty cool. So let's ignore these. Let's get rid of this coloring for now because it's a little bit too much. If this is 7, though, these 2 cells sum to 7. And then these 2 cells sum to 7. So if we cancel out the shared digit, if these 2 are 7 and these 2 are 7, then these 2 would have to be the same digit. So that doesn't work. So this can't be a 7. Now I'll delete these again, because if this is 9, that means these 2 cells sum to 9 and these 2 cells sum to 9. So again, we can get rid of the shared digit here, because these 2 are 9 and these 2 are 9. So therefore, these 2 will have to be the same digit, because this is in both sums. Oh, that's cool. So in this case, these 2 are the same digit, because both this sum and this sum is 9. But if these 2 are the same digit, they both add to 9 along the arrows. This one sums with this one, and this one sums with this one. So that means these 2 would have to be the same digit, because purple plus blue would have to be 9, but then purple plus blue is 9, but then also purple plus blue is 9. So blue, this whatever digit this is, would end up in the same cell, in the same box. That's very cool. I hope that's clear how I did that, but what we can say here now is this is actually has to be a 6. This cannot be a 6. Okay, and I won't get rid of my colors yet because we know that, again, these are from, this can't have a 3 on it because it's in the same. So it's either 1, 5 or 2, 4. These could be 3, 3, but they can't because of this. Okay, so these 2 cells sum to 9, so this is either a 1, 8, which it can't be because of the 6 here, so that's not 8, that's not 1. This could be 2, 7, which again would break the 6 clue, so that's not 2. And if this is 4, 5, then this is the 1, 2. So then this being a 4, 5 means this has to also be a 4, 5. And this is what we did earlier. I was kind of looking ahead a little bit. Okay, so this is a 1, 2 pair. And now this has to be, if this is 1, this is 6, which doesn't work here. So this is 2, this is 5. This 5 makes this a 4, which makes this a 5, which makes this a 1. Nice. That's a really cool break-in. I don't think I've ever seen anything quite like that, so I'm happy to see that. This 8 cage here now can't have a 1 or a 2 in it, so this needs to be 3, 5. And then we've got our high digits left over here. I won't pencil mark that quite now, just to avoid cluttering the grid. We might be close to being able to work out this here, using kind of the tricks we did over here. And I'm tempted to look at 8. So let's actually do that. I'm going to get rid of these colors again because I don't think we need quite that much coloring. So if this is 8, we know that these two cells sum to 8. So we're going to have blue plus yellow equals 8, whatever order this 3, 5 pair is in. But then this is also blue plus yellow must be 8. So this would also have to be yellow. But then blue plus yellow is 8, so this would have to be blue. And then we get 2 blues in the box again. So you get the same problem here. I'll actually leave the colors in here. So this is not 8. No, it's going to be 7 or 9. So if this is 9, this could be, it couldn't be 3, 6 because of this 6. So it would have to be 5, 4. And if this is 7, this is either going to be 3, 4 or 5, 2. Those are the only options. So this is either a 2 or a 4. Looking here, if this is 7, this is 3, 4. That can't work. That's pretty cool. So if this is 7, if we try to put a 3 here, let me put these in just so it's easier to visualize. This would be 3, 4. But then we need to make this sum to 11, so we would need to do 4, 7, and then we break column 3 here. So if this is 7, this can't be 3, 4. This would have to be 5, 2 with a 9 here. So that's if this is 7. If this is a 9, this would be 5, 4 with a 7 here. That would work. So we'd be 5, 4 with a 7. Or it could be 3, 6 with a 5, which doesn't work. So this is 9. This would be 3, 6, and then the 6 plus 5 to get 11 and for the cage, but that 5 is already there. That's interesting. So we got a 2, 4 pair here, and then we've got a 7, 9 pair here. So that does take one option away from our 8 cage. It can't be 1, 7 anymore. So this is either 2, 6 or it's 3, 5. Okay. I wonder if there's anything else that's going on here. I wonder if 9 can be rolled out using this 9 cage now. I'm going to go ahead and get rid of these colors because we've used them already, and I'll use colors up here now. So if this is 9, we know this is also 9, this sums here. So I'm going to use blue and yellow again. So we know blue plus yellow equals 9, whatever digits are in them. So if this is 9, that means blue plus yellow has to equal 9. And again, yellow plus blue has to be 9, and we get 2 blues in the box. Very nice. So this can't be 9, this has to be 7. And now the way this works, so this was a 9, this is a 2 to make the 11 cage work. This is a 4, 7 equals 4 plus 3, and then 7 equals 2 plus 5. And that all works here. So now this can't be 2, 6, it's a 3, 5 pair. We can use some Sudoku here. So the 5 is in box 1 up here, and the 3 is in box 1 up here. The 4 looking down can't be in these cells, so the 4 is down here and then up here. Looking over the 4 goes in one of these cells. Okay, that's cool. So the 4 cannot be here. If the 4 is in row 4, column 6 here, that's going to put a 2 here to make this 6 work. So let's just put that in, a 4 and a 2 to get this 6 arrow to work. But then this 2 needs to go with a digit to make a sum of 9, so that would have to be 7, and then we break the 7 arrow. So actually, the Sudoku goes a little further. We can take 4 out of this cell. Now 4 is locked in the 9 cage, so it must go with a 5. Oops. So there's a 4-5 pair here. For the 6 arrow, this has to be 4 plus 2 or 5 plus 1. And for this arrow here, this has to be 5 plus 2 or 4 plus 3. So if this is 5, this is 2. And if this is 4, this is 2. So no matter what, there's a 2 here in one of these 2 cells. And then this 7 looks up, this would be 5, 2, or it would be 7 plus 4 equals 3 plus 4. So we need a 3 here to get 3, 4, 7. And we got a 2, 3 pair here, which means the 17 cage can't have a 2 or a 3 in it. What else can we get? 1's looking over, so 1 is in these cells. Oh, this one here. Okay, so this 6, this has been available for a little while. I didn't get this earlier, but this 6 arrow can't have 1, 2, 4, 5 in this cell. And it can't be anything higher, 6 or higher, so this has to be a 3. And the case I talked about before where you had to repeat digits on an arrow, this has to happen here now. This can't be 1, 2, 4, 5, so this has to be 3, and this is a 3. That makes this a 2, this a 3, 7 equals 3 plus 4, and then we get 4 plus 2 equals 6, and then that makes this a 5. Very nice. This is very smooth. The break-in was tough, but so far it's been flowing really smoothly from there using the similar tricks. Looking down, this 2 goes here, but it's not in this cell. The 1 in box 5 goes here, which means in box 4 it goes up here. I'm looking at my low digits because I know we've placed a lot of them already. 2 by Sudoku looks into box 4 and goes here, and then that looks up and goes up here. We got 3s, 1s, 2s going across, 4s, 5s. 6 is going to be down here in box 5 by Sudoku. And so the 6 then in box 4 goes up here. So this cell here can't be 1, 2, 3, 4, 5, 6, 7, or 9, so this has to be 8. This is a 1, 6, 9 triple. The 9 looks up, so that's not 9. And now the remaining digits in row 4 are 7 and 8, which makes this cell a 9. So 9 in box 5 has to go down here. And actually, it's a little bit easier. We can just look here, and we need 1 and 8 left. And so we need 6, 7, and 9 to finish off box 5. Okay. Now I noticed this is starting to get a little restricted. So looking at what we still need in column 3, we still need 1, 2, 4, and 6 in these cells, because we already have a 3, 5 pair, 7, 8, and 9, so we need to place the remaining digits here. This can't be a 2 by Sudoku, and this can't be a 1 because this is in an 11 cage, so this cell would have to be 10. So this is either 4 or 6, and it can't be 6 because we need a 5 here, and that'd be 2 5s in column 2. So this is a 4, this is a 7. 7's look down, so 7 goes over here along with the 4. And now these don't have a 4. They do have a 2 up here, so with the 1, 2, 6 triple left in the column. These cells can be 1, they can't be 2, 3, 4, 5, they could be 6, can't be 7, so they could be 8. So from 1, 6, and 8. 3's here. Okay, that might be all we can do. Well, maybe not. What about this row here really quick? We still need 1, 5, 6, 8, and 9. So this cell, it can't be 1 or 6. So this is 5, 8, or 9, just by Sudoku. It can't be a 5 in a 2-cell 10 cage because we need two 5s in the column. And it can't be 9 because it would need 9, 1, and there's already a 1 in the column. So this is an 8, and this is a 2. That takes the 2 out of this cell, and we get a 1, 6 pair in the column. The other way of seeing that is we got 4 2s looking into box 1, so the only place for 2 is right here. So again, these are 1, 5, 6, and 9. You can't have 5 in either of these two cells, so these are from 1, 6, and 9. And this can't be a 9 because it's along an arrow. This would have to be an 11. So this is 1, this would be 2, 3. And if this is 6, this would be 2, 8. So that's a 3 and an 8. This 8 cage can't have 2 or 3 in it, and it can't have 4 in it because it would be double 4, so this has to be 1, 7. That 1, 7 looks down, making this 8 and this 1, and then the ones by Sudoku need to go down here. Okay, column, well, this 1, 7 also rules 7 out of this cell. So we have 4, 5, 6, and 9 left to place in this column. And this can't be 5 or 9, so this is 4 or 6. If that's, oh, and it can't be 6 because that would put a 5 here, but let me just double check that. This column has 1, 2, 3, it needs 4, it needs 5, 6, it's got a 7, it's got an 8, so yeah, 4, 5, 6, 9. This 5, 9 looks over, making this 4 or 6, and this can't be 6 because we'd get 2 5s next to each other. So that's 4 and that's 7. So we've got a 5, 6, 9 triple in column 6, and the 5 goes here. This is a triple in the column. We have 1, 2, 3. We need 4, 5, 9. And the 5 is already in this box, so 5 doesn't go here, and it's already in this cage. So we can't repeat 5 in the cage. So that 4, 9 looks like making this 5. Very smooth puzzle after that break-in. Very nice. I'm enjoying this a lot. We've got a 4, 9 pair here so that we can't repeat 9 in the cage. So this is a 5, 6 pair. That looks like making this a 9, taking 9 out of these cells. Okay, so we know the sum of these 4 cells. We've got 4 plus 9 is 13, plus another 11 is 24. And so these two cells need to sum to 5. So, and it can't be 1, 4, so this has to be 2, 3. And the 2 here tells us the order. This is 3 and 2. So just double check the math. 5 plus 11 is 16, plus 4 is 20, plus 9 is 29 for the cage. We haven't repeated any digits, so that looks good. Okay, so what do we need left in this row? This isn't 7 anymore, and it's not 4 anymore. So this 4, 7 looks over here, and now these 4, 7 corner marks, these are the only places for 4 and 7 in box 7. So this is a trick you can use if you use the Snyder corner mark notation. 4 is locked into 2 positions, and 7 is locked into the same 2 positions in the box. And so therefore you know that this has to be a 4, 7 pair, because if you put any other digit here, one of these two would have to contain both 4 and 7. So this becomes a 4, 7 pair. So this cell is from 1, 6, and 8 because the other digits are already taken up. So we've got a 1, 6, 8 bet triple here. Looking across, again, this row also just needs 1, 6, and 8 left. And I don't see those restricted by any digits looking down. What haven't we used yet? We've got these arrows done. These cages are mostly done, except for we don't have this arrow done yet, and we don't have this cage done yet. Okay, so let's take a look at what digits we have left to place in this box. This can't be 1, 2, 3, 4, 5, 6. So this is from 7, 8, and 9 here. The 5s look up here, so there's 5s in these two cells. 6s we don't know enough about yet. The 4s look up, and 4s are in one of these two. Okay, that might be all we get. Okay, so if this is... This can't have 2, 3, and 5 in it. So these 3 have to add to 17 without using 2, 3, and 5. So I'm going to use the killer calculator here just to shortcut the math a little bit. So the two options left, if we can't use 2 or 3 or 5, we have to use 179 or 467. Okay, and that's ruled out here. This 4 here means, and this 4 here means 4 can't go in this cage. So the other way to think about this, if you don't want to use the killer calculator, is this cage cannot contain 2 because of these two 2s looking at the whole box. It can't contain 3 for the same reason, and it can't contain 4 for the same reason. And it actually can't contain 5 for the same reason. So if we don't use a 1 in this cage, that means the minimum we can have in here is 6 plus 7 plus 8. If I could do math, which is 21. So this cage has to contain a 1 in it. And if it contains a 1, it's in one of these two cells. So the other two cells in the cage need to sum to 16, 17 minus 1. And so if this contains a 1, this would have to be, it can't be 6 plus 10, so this would have to be a 7. One of these just have to be a 1, and the other cell has to be a 9, so this has to be a 1-9 pair, and this 9 tells us this is 1 and this is 9. That's the other way to do it if you don't want to use the killer calculator, is just figure out what your minimum sum is, say if you omit the 1 in this case. So we get a little more Sudoku here. This 9 looks over making this 4 and 9. This 4 looks over making this 7 and 4. The 1 is still down here. Just making sure we haven't gotten anything else looking up into these cells. This 9 makes this isn't 9, so this is a 7-8 pair. And the 7 tells us this is the 8 and this is the 7. 8 moves 8 out of here. 8, 8, so 8 is in one of these two cells by Sudoku. Can't go here because of that. Okay, 2 in row 9 can't go in any of these cells, and it can't go here because of this 2, so that's a 2. What does this box still need? 1, 3, 6, and 8. Don't really see how to narrow that down yet, but this is a triple here. This will be helpful. So this needs to be 5, 8, and 9. This can't be an 8, and this can't be a 5. So we can take our corner marks off of this, and so then this is a 4, 6 pair. You need to look at the column or the box for that. So that's 4, 6. Three is over here. I know I'll be missing a trick here. I wonder if the only thing left that we haven't used, I think, 1, 3, 5, 6, is this. Sorry about that. I was staring at the grid for a while, not seeing anything useful and missing basic Sudoku. So instead of you watching me flail around a little bit, I'll just point out that this 8 sees this cell, which nicely resolves the rest of the Sudoku. Thought that would be weird to have a difficult trick here in the middle of the Sudoku that's been so smooth up to this point. So that makes this a 3 because it can't be 8, which makes this a 1. So that gets 1 and 3 out of here. This 1 looks over, taking 1 out of this cell and also out of this cell. We need 6, 7, and 8 left in column 8. We got a 6, 8 pair now in box 9, so these are 1 and 3. Okay, I'm sure there'll be another trick here that the 3 can't be in this cell, so the 3 goes here. Let's see what else we can find here. Fours in these two. What is this going to be? 1, 6, 8, and 9. 4, 6. Oh, this can't be 8. So this is 6 or 7. That 8 is giving me fits this puzzle. So these are from 4, 6, 7, and 9. I don't think is resolved yet. We've got a 1, 6, 7 triple here in row 2. So that means that none of the other cells in the row can contain 1, 6, or 7. And namely, this can't be a 6. So that's a 4 and a 6. This is a 4. Okay, so this can't be a 6 anymore. 170. Oh, this isn't 5 because of this 5. So this is from 1. It can't be a 7. So this is from 1, 8, and 9. We got a 1, 8, 9 triple here in row 1. So this is our 7 and our 1. That 1 looks over here, making this a 6. Taking 6 out of this cell and making this a 1. Taking 1 out of those. This 6 also looks over here, making this a 7. This an 8. This a 7. This 8 looks down, making this 6 and this 8. This 8 makes this a 6. This a 1. This an 8. The 1 makes this a 3 and a 1. The 3 makes this a 5 and a 3. And the 5 makes this a 6 and a 5. Now we're cooking here. We got a 5, 9 pair in row 3. So that's a 6. The last cell in this box needs to be a 9. That can't be 9. So this row still needs a 5 and an 8. This 6 look up, making this a 9 and this a 6. This 9 makes this a 5 and this a 9. And that's an 8 and that's a 5. The 5 makes this an 8. And this is a 1, 9 pair. This 9 looks up, making this a 1 and this a 9. And that is Sistine Hippos. This doesn't include a solution, but I'll verify here with GlemHippo to make sure this is correct. Excellent puzzle, GlemHippo. I love that break-in idea with kind of these, you're hiding here the normal way that you would whittle down the arrow cells by summing these digits, and instead using killer cages to force, like if you match the digit here in this arrow with the killer cage, it kind of forces duplicated digits because we got a whole bunch of 2-cell sums looking at one another. I really like that idea. It's not something I'd seen before, so very novel and cool. And then after that, we used that trick again here in box 5 to disambiguate this one. So we got to use, once we found the trick, we got to use it multiple times, which is always something that I like seeing in puzzles. But great puzzle. I hope you all tried it and had success with it, or if found this video helpful. That's all I have today. Thanks so much for watching. Take care, and we'll see you again soon. Bye-bye.